Today we reviewed what we have known from the past. We're just covering everything so that we can be ready for our benchmarks on Wednesday, Thursday, our cumulative right before the finals, and our finals. So let's start with domain. We go from arrow to arrow, so it's negative to positive infinity. Our range, we start right here at the really, really low, so negative infinity up into positive 7. End behavior over here as x approaches negative infinity, f of x approaches positive infinity. And on the right, as f of x, as x approaches positive infinity, f of x approaches negative infinity. Okay. Increasing. This part right here is increasing. It increases right up into positive 3. So from negative infinity to positive 3. That's increasing. So that means this part over here is decreasing. So from positive 3 to positive infinity. That's decreasing. There is a maximum value here. Max goes from increasing to decreasing. Maximum value at 7. There is not a minimum value. Here, our domain goes from a negative infinity and it stops at a positive 2. 2 gets the bracket, infinity gets the parentheses. For range, it starts at negative infinity and stops at a positive 8. End behavior on the left side as x approaches negative infinity, f of x approaches negative infinity. And on the right side, since it's a solid dot, there is not end behavior. This is increasing. If you put a little roller coaster car here, you would only be able to go up from left to right. So increasing goes from negative infinity to positive 2. There is no decreasing at all, so not applicable. So in order to have maximum value, you have to go from increasing to decreasing. And in order to have minimum value, you have to go from decreasing to increasing. Neither one of these is what this graph looks like. So there is no max and there is no min. Last one is top section. Domain goes from negative to positive infinity. Range goes from a negative 7 to a positive infinity. In behavior on both sides, as x approaches negative or x approaches positive infinity, f of x approaches positive infinity. It is increasing on this right side, so from negative 2 to positive infinity. It is decreasing on this side, so from negative infinity to negative 2. Notice how for increasing and decreasing, it's always on the x-axis, not what's on the y, but what's on the x. This is a min value, so our min value is at negative 7. There is not a max. We also covered the bottom section. It deals with restricted ranges and restrictions on graphs. So on numbers 4, 5, and 6, I wanted everyone to use their calculator. So in this first one, you're going to plug in 3x minus 5 onto your y equals screen. Now that you've done it, you hit graph to see what it looks like. The vertical line right there. And then we hit second graph to find out what the points are. So, -1 is at -8. Notice that that is a less than symbol, so it would be the same symbol here. 0 is at -5. 1 is at -2. 2 is at 1. And 3 is at a +4. Notice that that last circle is open. This first circle right here is closed, or first is open, last is closed. So y goes between. Notice that the notation is exactly the same, and then over here +4. We're going to do the same thing for these two. We're going to plug them in our calculator, see what we get. So on this one we have x squared minus 4. So if you hit graph, this is what the graph looks like. It's a parabola, but we're only going to plot it between -3 and 1. So we go to our table and scooch up just a little, so we start from -3 to a +1. So -3, +5, -2, 0, -1, -3, 0, -4, and 1, -3. So it looks just like, oh, sorry, just there. Alright, so our restriction range is from really, really low to really, really high. So from -4 to +5. Alright, we have one last one. It's an absolute value. So we go back to our y equals, clear it, and I want to show you how to do the absolute value. Now the negative is first, so we'll put the negative in. And absolute value is when you hit the math button, scoot to the right, and there's absolute right there. Hit enter. Alright, we're going to put in 1/5 times x plus 2, so 1 divided by 5, open parenthesis, x plus 2, close parenthesis, go to the right to get out, and we add 6. So hit our graph, it looks just like this. We're going to draw the entire graph. Again, go to your table so you can see that -2, 6 is that vertex that we saw. Parent function, y is equal to absolute value of x. If we scoot all the way up, we can see that -7.5 is another point. And if we scoot all the way to the right, 3.5 is another point, and so is 8.4. So 3, 5, and 8.4. So our vertex was at -2, +6. It is a max. Value of max is 6. The range, our range goes from -infinity to a +6. We're going to solve for the x and y intercepts. The easiest one is y, so we plug in a 0. So we're going to do -1/5 times 0 plus 2 plus 6. So y equals -1/5 times 2 plus 6. So y equals, and if I take this out, this is a negative. It was already there, 2/5 plus 6. And -2/5 plus 6 will give you 28/5. Alright, for x-intercepts, that's when y is equal to 0. So if I plug in a 0 here, I'm going to get negative 1/5 x plus 2 plus 6 equals 0. So I need to move the 6 over by subtracting, so a negative 1/5 x plus 2 is equal to negative 6. These are both negative, so I can cancel that out. Oh, the negatives cancel because they're on both sides. So when you have absolute value equal to a number, when you remove the bars, you get it equal to the positive and to the negative. So multiplying by 5 gives you x plus 2 is equal to 30. Subtracting 2 gives you x is equal to 28. Here we're doing the same thing. We're going to multiply by 5 both sides. So x plus 2 is equal to negative 35. Negative 30. I'm tired. Subtract 2 on both sides. So x is equal to negative 32. And that's what we did today in Algebra 2.